All right. I assume all of you can see my screen. I'm assuming all of you are in the correct place. You are here at the Intro to Hockey Analytics with our workshop. I hope you have, enjoyed some of the other conference offerings today. My name is Meghan Hall, and kind of before we get started into the workshop, just a little bit of housekeeping. At the bottom of every slide, I have a tiny URL that links to basically this workshop page on my website. We're going to go over in a minute kind of the structure of the day, but just if you ever want to access the slides, you can yourself. If you probably if you want to access them later, but if you happen to miss something, you can also go back. And I also have a file with all of the code we're going to go through in today's workshop. Of course, all the code is going to be on the screen and we're going to talk through it. But I also have it all on GitHub in kind of one handy, .r file. Again, useful for if you need it during the workshop or later. But coding along in the workshop, as we'll talk about, and as if you read the email I sent this morning, you would know, is optional for today because we're kind of constrained on venue and time a little bit. That is totally optional. You can code along if you want, or you don't have to. But again, like I said, we will get into that in a minute. I'm assuming, since I have not heard otherwise, that you all can hear me and see my screen. But if that is not correct, please, or if anything kind of happens to go wrong throughout the presentation, please just drop something in chat. Oh, someone sent me a thumbs up. Thank you. This is also my first time running a WebEx meeting, so apologies in advance. I have practiced, but apologies in advance if something goes terribly wrong. And I did have the setting to mute everyone upon entry. You're more than welcome to, speak up with questions. As I also addressed in my email, we don't really have time to do like really individual debugging questions if you're getting a certain error, but I'm happy to address kind of those more specific individual questions later after the workshop. All right, but to get started, before we kind of talk about me, I just wanted to share a couple of assumptions I have about you all. I created this workshop with the assumption that people viewing it know a little bit about R and a little bit about hockey. The hockey part first, I think it's totally fine if you happen to know nothing about hockey. We're not going to get, super in-depth into like hockey strategy and terminology and things that you would need to know. So if you don't know a lot about hockey, that's fine. If you know a ton about hockey and you were expecting a lot of in-depth, hockey strategy and terminology, then I apologize in advance, but also wanted this to be a little welcoming for people if they were newer to hockey. And same for R. I think this will be most useful if you have some familiarity with R. You've used it before, you're familiar with syntax and like how to get data, etc. But I also think that this will be worthwhile even if you are super new to R. I think it will be a good showcase of some of the things that R can do. And I would probably recommend that you just kind of watch and listen along and kind of absorb everything. And then later you can look through the slides again, look through the code and kind of use it as a learning exercise. And if you know a ton about R, well, I certainly hope that you still get some tidbits of information, perhaps specifically, some ways that you can use R to make your hockey analysis more effective. But if you are a super R expert, then you probably will want to be coding along and maybe you're even doing, more with kind of the data that we're working with today. Either of those, again, totally fine. I tried to make this is who the workshop is targeted for, but I'm hoping that we can kind of still capture people's interests, even if you're, whatever spectrum of knowledge you are, wherever you're at kind of on these topics. But about me, the things I do mostly for money, which I'm lucky enough to also like the things that I do for work. I've worked in the higher ed industry for several years and I'm a data manager. And I also work professionally in sports analytics. I'm a data scientist at Zelus Analytics, which is a sports analytics company. And there I focus mostly on MLB data, on baseball data. And then the things I do that are mostly for fun and also sometimes for money. Got interested in doing hockey analysis a few years ago. So I have, written my work. I'm a member at Hockey Graphs and right there. I've presented various hockey analytics research at several conferences. And then also kind of through that really got into learn that as I was someone who kind of taught myself R within the past few years, really had an affinity toward beginners and helping people learn R, particularly people who were kind of coming to R from a sports analytics interest, just because that's how I became familiar with R. So I do a bunch of tutorials and workshops I have a bunch on my website. I do workshops at conferences like this. I also teach sometimes more, I guess, standard traditional courses. I taught a data viz course at CMU earlier this summer. So that's kind of the other half of all the things that I do. But today's agenda, kind of as I've mentioned before, today we're really just going to explore how various aspects of R makes it easier to do your hockey analysis. That's a lot to do with data manipulation. Anytime you're working with hockey analytics, sports analytics in general, it's very rare that you have exactly the data that you want in the format that you're going to need. You often need to be able to rearrange, manipulate your data, look at different levels of observation, different levels of detail, different aggregations, etc. And making all those changes is quite easy through R, specifically with the tidyverse. If you're not familiar with the tidyverse is a collection of packages. And in case you're really new to R, packages are basically, you can think of them kind of as apps on your phone, as ways that collect a bunch of different functions together that let you do things. But the tidyverse is a collection of packages that kind of share a similar philosophy, opinions about data work. So we're going to look at several tidyverse functions that are helpful, that again make your hockey analysis easier, and same with data visualization. And we're going to introduce a couple of sports specific packages as well, within the R universe, that again make it way easier to do your hockey analysis. And to do that, we're going to go through a basic hockey analysis question. The question that we're going to address is, as it says, fairly basic. That's partly because we have a limited time frame. I at least cannot do groundbreaking hockey analysis research in 45 minutes. And as I said, I wanted this to also be welcoming to someone who is new to hockey in general. So I didn't want to have to address, go through some examples that required a lot of previous knowledge about hockey. So we're going to go through a basic hockey analysis question, basically by looking at the day in the life of an NHL power play. And as I had mentioned before in my email, coding along with me as I'm going to kind of walk through a bunch of steps is completely optional. I did include, if you saw my email this morning, I did just include for your own knowledge the list of libraries that we're going to be using and the ways to get the data that we're going to be using, in case that might save a little bit of time. But again, you are totally more than welcome. I often, when I do workshops like this, just like to kind of listen and absorb and think it through, and then go later and kind of play with the code at my own speed, so I don't feel like I'm missing things. But again, choose your own adventure kind of day today. So the first question, if you are, again, new to hockey analysis, as it would be in any sport, is like, where in the world is my data? What actually do I have access to? And the, I guess, good news is that there is aggregate data that's freely available for most hockey leagues around the world. The quality of that data definitely varies based upon what league you're looking at. But for most leagues, certainly in North America, you can find pretty easily like basic box score hockey stats. So you're talking about, the number of goals, the number of points, etc. in a given game. Those kind of things are available on league websites. And also kind of a really good resource for that also is eliteprospects.com. For some of the more popular leagues, I suppose, the more high profile leagues like the AHL, which is kind of the AAA of hockey, and the CHL, the Canadian Hockey League, which is the top junior league, on their website, they do have some event data where if you are, say, proficient with web scraping, I know there's a web scraping workshop also today, you might be able to scrape, certain events that at this time, this event happened, at this time, this event happened, things that are give you a little bit more detail than just, the box score of a game. But the real downside for this aggregate data that's available is, for these kinds of leagues, there really isn't any data that's available on time on ice, which is, again, when you're talking about skaters, non-goalies, the amount of time that skater spent on the ice. It's often not available in these kind of box score aggregate manner. And the rare event data that is available generally is not detailed enough for you to be able to calculate that on your own, which I think is a real bummer and is kind of a real constraint for doing any kind of non-NHL hockey analysis. To kind of put it in perspective with another sport, it would kind of be as if you were doing baseball research and you were trying to evaluate pitchers, compare pitchers, and you knew that in a given game, this pitcher gave up 1 run and he had 4 strikeouts. I mean, that's some information, but if you don't know how many innings that pitcher threw or how many pitches he threw, you're really losing a lot of valuable context there. You're kind of missing your main denominator for, the rate stats that you would want to calculate. It's certainly possible with data that you have for like college data, like NCAA, to see that this player had averaged like 0.75 points per game. And again, that's a very basic rate stat, but without having the actual time that that player spent on the ice, especially compared to other people, is a real negative for that type of data. So again, that's a major constraint with working with non-NHL data. Another interesting data source, as I've also linked to it here in the slides, is the Big Data Cup, which was a data competition presented by Stathletes, which is a hockey statistics company. The data competition is over. It was earlier this year, but the data is still available. It's some pretty fairly detailed play-by-play event data from some women's hockey games and also some junior hockey games. So that's also interesting data to play with. And then lastly, there are often these kind of specialty data sources that are often available for a fee. If you support someone on Patreon, you can get access to their data. These links that I've shown here, there's kind of these sources for women's hockey data, the CHL, which is again kind of the main Canadian junior hockey league, and also for the NHL. And when you hear about microstats in hockey, that's often smaller statistics that are not tracked in kind of a standard, in kind of the standard box score. So maybe zone entries or pass assists or things like that. And so it is, not surprising that the best resource we have for hockey data is NHL data. The NHL provides online, basically, they provide shot maps and they provide these HTML game reports that are very easy to scrape them. And you don't even have to know anything about web scraping because there's a great new package, new for this season from Dan Morse called Hockey R that makes it very easy to scrape NHL play-by-play data. There used to be scraping functions that were available if you've ever done any hockey analysis work. You're probably familiar with Josh and Luke Youngren, who still run the Evolving Hockey website. They had some very useful scraper functions, but Dan actually put all those functions into a package. It's on CRAN that you can download called Hockey R that just makes it way easier, especially for beginners. And there are some other helper functions in Hockey R that help kind of assist with analysis. So we're going to look at those too. So again, you're probably familiar with this list. If you looked at the email that I sent this morning, if you're interested in coding along, these are the packages that we're going to use today. I mentioned the tidyverse. When you load the tidyverse, it loads a bunch of different packages, which will encompass all that we're going to use today. I also like to bring people's attention to the janitor package, which is kind of a smaller, not as well-known package, but has a couple of really handy functions for cleaning data, as you might expect from the name. Hockey R, we discussed, best source for getting NHL data, and Sporty R, which we will discuss closer to the end of the workshop, is another super handy package that's useful for plotting location data. So you can create shot maps on a rink, and we'll look at that as well. And then those last 3 packages are just some kind of extra nice to have packages for creating nice tables and plots, which we will also do toward the end of the workshop. All right, so these are a few of the sample functions that are available from the Hockey R package. This first one here, scrape game. You can scrape the play-by-play data from an individual game. Every NHL game has a unique game ID. There's also scrape day, which allows you to scrape, again, all the games from a particular day, and even scrape season. Dan has a lot of data in his package, or the functions can scrape data from many years going back, I think back to like 2008. I want to say, and you can also specify whether you want to scrape just regular season or just playoff games or everything. And so what we're going to do today is, it's less interesting to look at one day's worth of games. Of course, you can't really make a lot of conclusions from one day's worth of games, but mostly just for space reasons. If you scrape an entire season of data, that's I think close to 1 million rows. 1 million observations of data, and I don't like to presume that everyone has that much memory on their computers. So today's data that we're going to look at is just play-by-play data from one day from last season. I think it was 14 games worth. And again, if you're coding along, you can use this function if you want. It will take a couple minutes because it's scraping. Or if you see in this, in my code file, I do have this data saved as a CSV on GitHub, so you can read it in directly from there, which is faster. So up to you. Again, whenever you're doing this code, whether that's now or later, you can do either of those options. But I wanted to show you how I got the data. I just got the data from doing this exact function. Okay, so I've mentioned play-by-play and event data kind of a lot. So what do I mean when I say that we have play-by-play data, also sometimes known as event data? It is at the structure, as you might expect, where we have one row per event. And there are lots of different variables associated with that event. This play-by-play data file that comes from HockeyR has 105 variables, which is a lot. Most of the shot type events, like a shot or a goal, a missed shot, a block shot, etc., has a location attached to it, an X and Y coordinate that just corresponds to wherever that shot was taken on the rink. We'll discuss how to use that later. Also, along with the players that were on the ice at that time, the time in the game, the score of the game, the strength state, the goalies who were on the ice, etc., etc. Just again, because of time, we don't have time to go through all 105 variables that are available, but I highly recommend that you take a look at that, again, if you're interested in continuing to work with hockey data. So when I talk about events, what does that mean? These are all the events that are in this particular play-by-play data set. Again, this is 1 day's worth of games. It was 14 games. I think the data ends up being around 8,000 or 8,500 observations. And as you can see, the vast majority of those are what's known as change events, which is when there was some kind of line change. Players were either coming onto the ice or leaving the ice, going back to the bench. That is super useful because it means you can calculate time on ice. And we know how long each player spent on the ice. You're able to calculate that, which is great. We're not actually that's not going to be a basis of our analysis today, but you can absolutely do that, which means that you can, of course, make kind of the best observations you can do the best analysis from NHL data than you can with other data, just because we have this time on ice data. And the other events that you can see might be what you expect. We've got face-offs, shots, giveaways, goals, penalties, etc. And so if you're familiar with hockey, you probably recognize that these events listed here are not all of the events in a given hockey game, of course. And so that kind of leads people to the natural question of, well, what about tracking data? Because particularly if you have any experience with doing analytics work with other sports, baseball, soccer, football, basketball, whatever, tracking data has become very popular, which is in essence being able to track not just, again, like we have with hockey data, just kind of what events happen and at what time. Tracking data allows you to have information about where everyone is, where the ball, the puck, etc. is at any given time. Much more granular, as you can assume, allows you to take a lot more observations, draw a lot more conclusions from that data. You might be familiar with the Data Bowl, the NFL runs, kind of the public data competition. They use tracking data in that. The NHL is at the very beginning of its journey with tracking data. They are just starting to implement that, and that data is not currently available to the public. Hopefully there will someday be some kind of NHL data bowl like we have in the NFL. All right, so I had mentioned that we're going to focus on a power play. We're going to look at the day in the life of a power play. And for people, again, if you are new to hockey, a power play happens when one player on a team does something bad, does something against the rules, literally gets sent to timeout, goes to the penalty box, and then their team is down a skater for generally 2 minutes. There are some exceptions, generally 2 minutes. One team will have 5 skaters and the other team will have 4. There are other strength states that can result from a power play, particularly if there are multiple penalties, etc. But the most common strength state during a power play is one team has 5 skaters and one team has 4 skaters. So we're going to basically filter all of our data to only those types of scenarios. I only want events that happened during a power play, meaning that the strength state was either 5 versus 4 or 4 versus 5. So I can get my data down to that format by using a lot of the tidyverse verbs that you may be familiar with if you're familiar with R. Mutate is, again, for creating new variables. We're going to create this new variable for a power play team to specify who our power play team is. We can filter. I mentioned that I only wanted games that are, within a certain strength state. We can use select, which is like filter, but filter focuses on rows and select focuses on columns. I mentioned that standard play-by-play data from HockeyR has 105 observations. We rarely want all 105 variables, so being able to select is helpful. And then this remove empty is a really neat function that comes from the janitor package that, again, will just, as it say, will remove any columns or rows that have all NA values. So it's just a nifty function to know. So we end up with data that looks like this. In most of these data screenshots, there are often more variables than I'm showing here, and certainly more rows. I'm just showing a subset. So I don't want you to be confused if you see a variable in a select function that then does not show up in the chart, or sorry, in the table here. So this is a subset. So this is what our play-by-play data looks like, at least a selection of it after I have filtered to power play events only. Very important whenever you're working with any kind of data is to immediately identify whatever your unique identifiers are. Here we have, as I mentioned before, a game ID uniquely identifies every game. An event index uniquely identifies every event within a game. So the two of those together can uniquely identify any event. You can see here you've got face-offs and shots, etc. And with all of those, we have listed all the players who are on the ice. That's what I'm focusing on. There are many other observations that come along with this data, but we're mostly focusing on kind of what the event is, who the power play team is, and then who the players are on the ice. So the question I mentioned we have is we're going to look at a day in the life of an NHL power play, since we only have 1 day's worth of games here. And so to do that, I'm interested in looking at the positional breakdown of a power play. This is something that has changed over the past several seasons. When a team was on a power play, they used to maintain the same kind of positional structure that most teams have at even strength, which means they have 3 forwards and 2 defensemen. If both teams are playing at even strength in an NHL game, that is 99.5% of the time the positional breakdown. But it has become popular over the past several seasons to, when you're on a power play, again, when you have a skater advantage over the other team, that you actually use 4 forwards and 1 defenseman instead of 3 forwards and 2 defensemen. You're a little riskier defensively, but again, the main goal of a power play is that you have an offensive advantage, so you might as well kind of stack that offensive advantage by adding another forward. So that has become very popular. So we're going to look, again, this 1 day of games, we're going to look at kind of what the breakdown is, what teams use what kind of position structure on their power play. So this is the same screenshot as before. This is the data that we have. We have 1 row per event, and we have the players listed. But if I'm interested in knowing, like, for example, for this first event, the face-off that lasted 18 seconds, I know the players that are on the ice. So how can I figure out what the positional structure was of that team? I need to have position data for the first part, which I do not have. The position of a player is not included in the play-by-play data, but we do have it. So I'll get to that in a second. But in order, if I know I have that data separately, I probably need to join it in somehow to this data, which means I probably need to adjust the level of detail or the level of observation of my data. So this data, as you can see, 1 row per event. But I actually want to kind of turn this data on its head so that I have 1 row per player instead of 1 row per event. So I want to end up with actually like 5 rows per event that list every player on his own row. So to do that, there is a very handy function, and again, part of the tidyverse, called pivot longer, which again makes the data longer and kind of turns it on its head. So I'm going to do that here. And then I'm going to end up with kind of exactly as I wanted. This is that first event, that face-off, the event index of 37. And instead of having 1 row, I now have 5, 1 for every player, which is perfect because now I can kind of join in that position data and figure out how many forwards and how many defensemen this team had at that point in time. So another great aspect of the HockeyR package is not only can you scrape NHL play-by-play data, you can also get roster data, which comes from Hockey Reference. That uses the get rosters function. Or also, again, if you're doing this code, I also have that data saved as a CSV in GitHub that you can just read directly. Your option, choose your own adventure. So to do that, I'm just going to clean the data a little bit. There are some duplicates in that data because players can, of course, play for multiple teams in a given season. So I'm just going to get a unique list of players and positions, and it looks like this. Again, this is just a subset. So a couple of things that, the first thing that I should kind of notice is in hockey, it is not very common. We don't really have access to unique player IDs. So all the kind of joining and matching has to be done on name, which is not ideal, which we will kind of address the couple of reasons why that's not ideal. But the other thing that I personally noticed, first of all, is this data that comes from the rosters is kind of your standard title case. Names are capitalized with a space in between. But if we go back to our play-by-play data, we have a period instead of space. So a little bit frustrating, but nothing that can't be handled with these string replace functions. I'm going to get to that other problem in a second. So the stringer package lives within the tidyverse, has tons of functions that are great for manipulating string data. So here it allows me, I know that I need to replace spaces and hyphens with periods. Easy to do in just a couple of lines of code. The other function that I wanted to show off is this get dupes function, which again comes from the janitor package, which will show you any duplicate values you have in your data set based on whatever variables that you specify. So in this little couple of lines of code here, I'm asking for, do I have any player duplicates in my data set? Because, you know, if we don't have unique identifiers and we're addressing on name, there might be players that have the same name. And if you've ever done any work with hockey analysis, or if you do, you will quickly become familiar with the Sebastian Aho problem. A lot of people are familiar with the Sebastian Aho, who is a forward, who is the better, more popular Sebastian Aho, who plays in Carolina. But there's also a Sebastian Aho, who is a defenseman, who plays for the Islanders. So this is an unfortunate problem. Something always to keep out, always a annoying issue when you're dealing with names instead of unique identifiers, is you might have duplicates. But I happen to know the defenseman version of Sebastian Aho does not play very often. He did not play in these games, so I'm just going to filter him out of this data set. And then, as I mentioned, we can use our string replace functions, and now we have our player names that are in roughly the same format as we have in our play-by-play data. All right, so another kind of issue with dealing with names is we already addressed the possible issue that you might have duplicate names, but you might also have, if you're dealing with names from different sources, those names might have differences in terms of nicknames in particular. So what I'm doing here is this player data frame is our original data frame that came from our event data that has one row per player. And then I'm going to join in my position data here. And I'm going to filter for anyone who has a NA value, or basically didn't get matched, who kind of fell through the cracks. And I get this list of players. And I know from doing hockey analysis work that these players show up a lot. Often, again, when you're dealing with names, Joshes can become Joshuas, Mitchells become Mitches, Nicks become Nicholases. So this stuff is also very annoying to deal with, but happens whenever you have to join data with name, which happens in hockey all the time. So I would become familiar with this process. So anytime you're dealing with names, always look for duplicates, always look for any mismatches, anyone who kind of fell through the cracks. And then all you have to do, again, change these names, address either the middle name, or sorry, the full name, the nickname, etc. And then we can join in again, and we're going to create this variable called just forward. That's just a 0 or 1 variable that is determines whether someone is a forward or not, which will allow us to kind of sum up the number of forwards that any team has at any given time. So if I do that, again, this is back to our event data that became player level data. And we've joined in our position variable here, and then our dummy kind of 0, 1 forward variable. So this is very helpful. We've kind of made it to our middle step where I now know everyone who's on the ice and what position they play. And now I just kind of need to re-aggregate it so I can find kind of two things. First, at any given time, again, for this event index 37, this face-off, how many forwards did this team have? And then we can do another aggregation and see of all of the events and all of the time, how much time did each team have with 4 forwards versus 3 forwards. And we can do this with, again, just a few lines of code, particularly using the group by and summarize combination of functions, which is a very popular tidyverse combination of functions that basically serves as, if you're new to R, basically a pivot table in Excel. It groups and aggregates your data. So my first step, as I mentioned, you're going to group by our event index and our team. So now we're back to 1 row per event. And I've just summed up my number of forwards. So I know that at this event, this team had 4 forwards. For this event, they also had 4 forwards, etc. But for this event, they had 3 forwards. So that's kind of step 1. And once I have data aggregated that way, I can take and do another group. And this is where I'm going to group all the time, not just by event. I'm going to group all the time for that whole team. And I can see, for example, Arizona, in this one game they played, of all of their power play time, they spent 74 seconds. That's the main unit of time in hockey data. They spent 74 seconds with 3 forwards and 166 seconds with 4 forwards. And then next we can add, I wanted to show, I feel like this is not a function a lot of people know a lot about, this add tally function. It's a great shortcut because it groups your data and summarizes it without aggregating it. So you're not losing any rows, but you're just kind of getting your total value. So as you can see here, this add tally function has created this new variable called total time, which just sums up these two, gives you the appropriate denominator, really, to calculate a percentage. That's what we're doing. So for each team, like here for Arizona, it's just adding up this 166 and 74, and you get 240. And then we're just calculating the percent. So this is pretty standard. It's basically 31% versus 69%. And then lastly, I don't care about the percentage of time that they spent with 3 forwards. I only care about 4 forwards because that's my question. So now that I have done kind of all this aggregation, data manipulation, I have successfully gotten the data that I want. I have 1 row per team, and it shows me exactly what percentage of the game that they played, they had 4 forwards on their power play. So you can see Arizona was again at 69%, Buffalo 63%, and then we had a couple of teams, again, I mentioned this is becoming very popular, and so a lot of teams spend all of their power play time with 4 forwards, as you can see here in these couple of examples with Calgary and Chicago. So we have this little table here. This table is fine for just kind of showing you the result of the data, but if I were presenting this in some kind of fashion, whether that was, in a presentation or in a paper or really anything, I would want some kind of visualization that looks better than this. You could imagine some kind of nice table, perhaps. Spoiler alert, we're going to do a table and a plot with this data. But you can imagine some kind of table that showed the percentage, sorted nicely, maybe even colored according to the percentage. And then you could even imagine, perhaps, instead of just showing the team abbreviation, we could show the team logo. That'd be cool, right? Well, thankfully, that is also a super neat function within the Hockey R package. It comes with this data frame called Team Logos Colors, which, exactly as you might expect, contains all the logo links and team colors for every team. I didn't list all of the variables here, but there's also the alternate colors and even alternate logos, etc. So all we need to do, again, this forward data set, this FWD data set, is our endpoint, really, that had all of our aggregated data that we want to visualize in some way. And so all we need to do is join in this logos data. I'm only interested particularly in the logo in this primary color. And then we can use that and we can exactly create that table that we just talked about, where we have our percentages sorted here. We've got a little bit of color, even got a gradient. And then instead of showing the abbreviation, just for another bit of added interest, we can show the team logo. So I created this table with GT, which is a great package for creating any kind of HTML table. You could do an entire lecture on GT, so I'm not going to kind of go through all the details of creating a table, but it is fairly straightforward. And a couple of functions that I wanted to point out that are really useful, particularly what I use to use the logos, is this GT image rows function. And that basically is telling GT, hey, this column is not actually, this column actually contains a link to an image, and I want that image to show up in my table. So that makes it very easy. And the same, you can format a percentage, which is what we did. It's always nicer to have things formatted as a percentage than as a decimal. And then it's, again, really easy to just color a row. We colored that percentage row, and you can specify a palette, and we have it sorted. So just like that. And then if you didn't want to make a table, perhaps you wanted to take that same data and instead make a plot, you could do that as well. ggplot, which again, you might be familiar with if you are just familiar with R in general, it's kind of probably the most popular way to create data visualizations within R. It is part of the tidyverse, but I think a lot of people, even if they don't tend to use the tidyverse a lot, do use ggplot. And similar to how you could do a whole lecture on GT, I mean, earlier this summer, I taught a entire, semester length course on ggplot too. So you can do, you can go really in depth with ggplot. So I'm just, again, going to show very quickly, mostly just want to showcase how easy it is to create kind of publication quality, really nice plots and tables pretty easily with various functions in R, which are really helpful for your hockey data, because you can do great hockey analysis, but if you can't present it in a compelling way, people are going to pay less attention to it for sure. So this is the exact same data that we aggregated previously, the same data that we put in our table, and now we're just putting it in a plot. And instead of using the logos like we did in the table, here I just used those color values. So let me go back and show these team colors. If you're not familiar, this is a hex code, which specifies an exact color. And that is what ggplot uses. If you, I'll show you where you can put it in the code, and then ggplot just knows to make that bar that corresponds to that team using that hex code from our data frame. And same, we have things sorted. And so this also makes it easier to see that we have about half a dozen teams that only used 4 forwards on their power play. And then it kind of decreased from there. And we even had Minnesota, which is kind of known for this, the Minnesota Wild defensive team that still sticks pretty hard to their 3 forward, 2 defenseman structure on a power play. So how I did this, again, it's pretty easy, only, less than 10 lines of code, really, to make this kind of nice plot. And the one thing that I wanted to point out, how you can tell R that I want to use these hex codes that correspond to these teams, is just within this geom bar layer, which is the layer within ggplot that tells R to create a bar chart. You're specifying your fill argument, which controls the color. And here you're just going to put in exactly a direct reference to that hex code column. And that's all you need to do in order to kind of, again, create this nice plot with the colors, which is great for using anytime you're doing any kind of sports analysis work and visualization. It is often nice to use logos and colors associated with that team, just because people are familiar with those. People are familiar that Toronto, for example, is blue, Calgary is red, etc. So using other colors that don't necessarily match to a team's colors can be confusing. So having that data so easily accessible in the Hockey R package is really great, because before that you had to kind of load it on its own or use some other packages, and it was harder. So having that is a real selling point of Hockey R. All right, the other package I wanted to talk about that I mentioned earlier is Sporty R, which is another fairly new package. It's not quite as new as the Hockey R package, but it was created by Ross Drucker. I have a link to the GitHub page for that package here in the slides. And it includes tons of functions in order to aid in plotting all sorts of rinks, courts, fields, most sports in which you can plot, on a rink or a court where something happens. The Sporty R package has functions to create that for you. Before this package existed, it was not impossible, but definitely kind of difficult and not super beginner friendly to create basically an image of a hockey rink that you could then appropriately map coordinates onto. So having the Sporty R package makes it so much easier to create those kind of shot plots. So here's a very simple example just to show, and then we'll kind of, I want to show you another example as well. So to get the data for this plot, I'm going back to my original PowerPlay data frame, which was kind of the first step we did, which was just filtering our total play-by-play data into PowerPlay data only. And here I've filtered, again, I've created this new data frame called PowerPlay shots. And I've just filtered, all I want are shots on goal as well as goals. And I only want those events from the PowerPlay team. Now during a PowerPlay, most of the offense does come from the PowerPlay team, as you might expect. But there are generally a few shot events from the penalty killing team, but I didn't want to include those here. I just want to look at PowerPlay team. So all you need to do to create, again, this baseline rink is use this geom hockey function that comes from the SportyR package. The only argument necessary is we want an NHL rink, so it's NHL. And then you can use a standard geom point layer, which you might be familiar with from other ggplot work, to specify where the shots are. You can think of a rink as just a standard coordinate system. You have your X and your Y, got positive values to the right and up, and and negative values like to the left and down. It's a pretty standard coordinate system. And in the play-by-play data that comes out of Hockey R, there are two separate coordinates. One is just the raw X and Y, which is just where that shot was taken from. And also, this is super handy, there's also X fixed and Y fixed, which has a function already goes through the function that corrects the coordinates so that if you make a shot plot with that data, because often people will show shot plots from a given game or a given period in a game, the home team always shoots to the right and the away team always shoots to the left, which is really handy just for kind of general, when you're making general shot plots. So that's what I've done here. Again, I'm specifying the data that I want, and then my aesthetics, we're just plotting my X, as you might expect, is this X fixed, and then the Y is my Y fixed. So your super basic shot plot looks like this here at the bottom. But for my particular purpose, I'm just interested in power play shots, which is what these are. But I don't really care about the home team and the away team because this is like 14 games or something like that. So I'm not so interested in having the home team on the right and the away team on the left. What I want is I want all the shots on the same half rink. And I want them colored, as you can see here. I've echoed the color in my title. So this is showing shots and goals on the power play on a given night. So this example is more common, again, if you're looking at a given game, that's what people would expect to see. But if you're looking at some other kind of specific situation, maybe it's all goals by one player or all goals of a certain shot type, like all goals that were scored off a slap shot, for example, you might want to show everything on just one half of the rink because the home and away doesn't really matter in that case. So to do that, it does require a little bit of finessing of your coordinates. So I will confess, I am not great with spatial things like coordinates. Within the SportyR package, I assume most, if not all of you, are better with those kinds of things than I am. Within the SportyR package, there are really helpful functions that allow you to reflect and rotate and transform your coordinates. But I need to, because I'm not great with spatial stuff, I'm not great with coordinates, I need to think it through on my own and create my own functions to kind of specify what coordinates I need. So I've created, here in this example, my own X and Y coordinates because I want, this is just, if you can imagine, this is just the negative X coordinates, right, that we're showing here on the plot. But I don't want just, I want all the shots to show up here, not just the shots that actually had a negative X coordinate. So to do that, I just need a little if else. So I'm just going to say, if the coordinate was actually on the right side of the rink, it had a positive X, I'm just going to multiply that by -1. And same for the Y, because if you're moving your X over to the other side of the rink, you need to flip the Y as well. So same for the Y. If my X is greater than 0, then I need to multiply that Y by -1. I thought about this a lot, and I'm pretty sure it's right. But again, the spatial coordinate stuff is not my forte. And then we've, again, just doing a little sorting here. And then to make the actual rink, all you need to do if you just want this half rink here is just full surface equals false. That will give you a half rink. And there's also options if you want to rotate, like it's common with, I think with basketball courts, if you don't show the full court, you just kind of show, imagining rotating the court. You can also rotate the rink. That messes me up a little bit with the coordinates, so I just stick with half of a hockey rink. And the same as before, I'm just specifying what X and Y I want here in my aesthetic argument. And just like you might expect if you've worked with ggplot before, if you work with the geom point layer, like in making a scatter plot, you can adjust all of these aesthetics. I want my points to be a little bigger. I can also control color just by saying if it's a goal, I want it to be this hex code. If not, I want it to be that hex code. And same with alpha. Alpha is just, alpha means transparency here. And so if you'll notice the my goals, these kind of purpley red dots, are at full transparency, and just the shots are about half transparency. So I can do that again here with my alpha as well. And then everything else, just creating a title and subtitle, is fairly standard ggplot things. And that's how you can adjust your rink if you only want to show half of a hockey rink. All right, so we have made it through over 45 minutes of this workshop, and just kind of recap what we did. Explored, again, lots of different data manipulation techniques with the tidyverse. Looked at various stringer functions to help us deal with the issue of having to match on name, which is never ideal. We use pivot. There's also a pivot wider function, which we did not do, but does the opposite of a pivot longer, in order to look at our data from kind of a different level of observation. The way I need to think of it, instead of at the level of an event, we changed it to look at the level of a player instead. We use left joins a little bit to put data together, to add in logo data, to add in position data. And then of course, all the various dplyr verbs, selecting, filtering, mutating, grouping, summarizing, etc. And then hopefully I showcased how easy it is that once you have your final data frame, that you can make various visualizations with that. We made a table with GT and a plot with ggplot2. And hopefully again showed how Hockey R can be super useful because it has all those logos and colors that are so easily available, and you can just match them on your team abbreviation. And then lastly, using SportyR, a fairly new package for creating shot plots, and showed how we can create both a basic shot plot with your home on the right and the away on the left, which is what people expect generally if you're looking at a whole game, or if you're looking at a specific situation, like we were with power play shots, how to put all of those shots onto basically the same half of the rink. So we flew through a lot of information in the past 48 minutes. As I mentioned before, if you go through the code at a later time and you have any questions about either things aren't working, or you have specific questions about why we did things or things like that, you are always free to email me. You hopefully got an email from me if you were registered for the workshop as of yesterday. But if you don't, my email is available on my website. You can also find me on Twitter. If you have any, we have a couple of minutes, so if you have any kind of general questions, either about hockey analytics or working in sports analytics in general, I'm happy to take those. Feel free to unmute yourself. And I'll also hang around for a couple minutes after our session is over if you have questions as well. No questions? Oh, claps. Thank you. Appreciate that. Again, I know you might, there was a lot of information to go through in 50 minutes, so I assume that lots of you are gonna maybe hopefully come back to this code later. So I just want to reiterate, I'm more than happy to answer any questions via email about the code, or if you just have general questions about working in sports analytics or kind of how to get started in that field, I'm also available. But I hope you enjoy, hopefully this was helpful, gave you a little bit of an introduction to hockey analytics, specifically using hockey analytics with R. And I hope you enjoy the rest of the workshop.